So x what?
It's plus 3, but I thought if you're writing it, I thought you, well, I thought once you equal it to 0, then you make it the opposite, but you automatically write it in the opposite in the parentheses.
Yep, when you go from the root to the factor, you switch it. Or if you go from the factor to the root, the other way, you switch it. So when you go back and forth between the answer and the factor or the equation, you switch it either way. Okay, so positive 3, the x minus 3. And then what is special about that one? What is that called when it bounces off the graph? A double root. And what do we put here to account for that? Square it. All right, so that was what you guys were doing last week, okay? And then that's factored form, right? And then that one question at the end of the delta math asks you to multiply all this out, and that was the challenge, right? It was multiplying all that out. Now, this week, a little different. And what I'm going to do is kind of do this side by side to show two different examples. So let's just say I asked you to write the equation for these two x-intercepts. We'd say, okay, I do x minus 2 and x plus 3. And then I want it in standard form, so you got to multiply it. So I multiply it out. Okay, so I get x squared here minus 2x plus 3x and then minus 6. And you add up those like terms in there. So now I get x squared. These two add together, and that just is 1x or just x, and then minus 6. And there's my possible equation. Now, what if I give you this? What if I tell you the roots are 2 plus 3i and 2 minus 3i? What kind of number is that, by the way?
3i?
No, when you have like this part and this part, what do we call those kinds of numbers? Imagine this part's imaginary, that part is real. These are complex. Together, they're complex. So these are complex roots. So we're going to still find a possible equation, but using a similar method. I mean, basically the same method, okay? So what we're going to do here is I'm still going to set up those same parentheses. All right. And by the way, as I explain this, when you guys watch the Edpuzzle video of Miss Menard explaining this, the first step is still the same, but how I do it after that is slightly different. And you might like hers or you might like mine. I like mine personally because it's only one box instead of multiple boxes. It might be a big box, but it's just one box instead of doing 2 or 3. All right, so first, in both of these, by the way, I'm going to do minus. So I'm not thinking about, okay, if it's positive 2, I put a negative, or if it's positive 3, I put a, negative 3, I put a positive. You just put minus, okay? And you're going to want to put minus, actually, let me make this a little bigger. So first I do minus 2 plus 3i, and I'm going to have that within inside another set of parentheses. And I'll do the same thing here. X minus, except this time, that minus here, it'll be 2 minus 3i for the other solution. All right, so I'm going to do just one step to simplify here. So first thing I'm going to do is that because I've got a negative in front of these parentheses, I'm going to distribute that on both of these. So now I have negative times 2, minus 2, negative times plus 3i, negative 3i. And then over here, again, minus 2, but here it's negative times negative, so it'll be positive 3i. Okay? Now, I am going to have to basically do what I did here, where I multiplied, using the box, except the issue here is that I have x, 2, and 3i. Those are all different terms. I can't combine any of these. So now I'm going to have to create what type of box? 3 terms there, 3 terms there. I got to make a 3 by 3. So same thing, just bigger box. So I'm going to take that first factor over here, x minus 2 minus 3i, and then take the other one, x minus 2 plus 3i, and I got to multiply everything out. Okay, so now x times x, that's x squared, negative 2 times x, negative 2x, negative 3i times x. Well, there's nothing I can combine there, so I'm just going to write negative x, 3xi. Okay, so it's negative 3 times x times I. Okay, then here, that's also negative 2x. Negative 2 times negative 2, positive 4. Negative 2 times negative 3i, positive 6i. X times 3i again, so it's just positive 3xi this time. And then negative 2 times 3i, negative 6i. And there is hope in the end, okay? This does work out nicely, okay? Promise. All right, so, and then the last one here, negative 3i times positive 3i, that'd be negative 9. But I times I is I squared. All right, so let's now we've got all those terms inside. Let's start writing them out. Okay, let's first start with the top left, x squared. Do we see any other x squared terms? No, that's it. So just x squared. Now I go to the next two here, x. I see an x there, there. These two are not like terms to that because they don't have I. So it's just negative 2 plus negative 2, which is negative 4x. All right, then I'm going to go to negative 3xi and positive 3xi. What does that add up to? 3 and negative 3. What do you think? 3 and negative 3. What does that add up to? Yeah, it cancels. That equals 0. Okay. Then I got 4. So I'll write out the 4. And notice how I'm crossing them out every time I do it, right? What about 6i and negative 6i? That also cancels. So notice how 2 terms already canceled out. Now this one, before I write it down here, remember, what does I squared equal? Negative 1. So that means that this is negative 9 times negative 1. Because I have I squared, and it's equal to negative 1. So now I'm doing whatever that number is times negative 1. So here it's positive 9. And then the last step here is just to add up those like terms there, because now 4 and 9 are like terms. So now I have x squared minus 4x plus 13. Okay. All right. So just to rewind from the beginning, I had to do subtract both roots, both the plus and the minus. I distributed the negative, and I got 3 terms in each parenthesis, or each factor. Then I took these factors and multiplied them out using a 3 by 3 box because I have 3 different terms. Once I multiply all these out, I got to add up the like terms. And notice, and remember that 2 of them canceled. The xi terms and the I terms canceled out. So all I was left with was squared and x, and then this I squared. And every time you guys have an I squared, that number is going to turn into a real number because I squared equals negative 1. Okay, and then I end up with that. All right, so now that is how you write it out by starting with the roots of the equation, okay? Or the factors of the equation written out this way. The second method, and the reason I'm saying the second method is because when I go here to the packet, the very first problem for this homework assignment tonight asks you to basically do this two different ways. So when you go over here to the left, it's saying that this guy Spud has a problem. He knows that the roots of the quadratic function are 3 plus 4i and 3 minus 4i. But in order to get credit for the problem, he was supposed to have written down the original equation. So that little cute story is basically saying we need the original equation, okay, from these two roots. Okay, unfortunately, he lost his paper and he didn't have the original equation anymore, so now we got to find it, okay? So his first friend says, hey, remember when we had like plus 7 and plus 4, and it just became x minus 7 and x minus 4? Use that idea to find the equation. That's what we did here. I basically took those factors and subtracted them and then set up a box. Okay, so that's that first method. The second method is his other friend says, no, you can do it this way. You could do that way, but it's complicated. So let's try it this way, go backwards. He's saying, well, if x equals 3 plus 4i, work backwards. So like x minus 3 equals 4i, and then so on and so on. In other words, he moved the 3 to this side, and I'll show you how that works. In order to understand this, you got to remember completing the square.
So in the first problem, or the first method, we're basically just like foiling.
You're doing a big foil.
Right.
Okay, a 3x3 foil.
The second one working backwards?
Yes. So what I'm going to do is I'm going to start with the solution. And I'm going to start at the bottom because I'm going backwards. I'm going to go back up in the other direction. Now, you can kind of just see the method and see how it's done. To kind of really understand this, you got to remember how to complete the square. Okay. So before I do that, I'm going to do a quick example on how to complete the square and just review that. Okay, so when we complete the square, all right, what we were trying to do was find the solution to a problem without using the box, basically. So like, let's say I have this, actually, let me set it equal to 0. Let's say I had this problem and you tried to set up the x, right? And you did the 25, here you did the 8, and you're looking for two numbers, but it just didn't work. So you would do quadratic formula. The other method you could do was complete the square. So to complete the square, first I had to move this number over. So to do that, I subtract 25 from both sides. And then on this side, I complete the square. So this might start looking familiar to you guys with that little square. Remember, to get that number in the square, it was the b divided by 2, and then you squared it. So 8 divided by 2 is 4, and I square that, I get 16. Okay, and now what I had to do next, and then notice I added it on both sides, by the way. Now, when you work backwards, you don't have to worry about like adding to both sides. It's just this part that matters. Now I had to factor it. So I'll take my x out, I get 16 and 8. What two numbers multiply to 16 but add up to 8? 4, positive 4. So here is x plus 4, x plus 4, and then add these two up, negative 25 plus 16, that's going to be negative 9. I can combine these two together because they're the same thing, so I put x plus 4 squared instead. Now to solve this when I have a square, I square root both sides. Okay, and I get what happens here, if you remember, this cancels. and I have just x plus 4 now. But when I square root a negative number, it is 3, but I can't square root a negative, so what do we make it? 3i. Also, if you guys remember, when you square root something, you always had to count for 2 solutions. So in front of this, I would put plus minus. So this might be coming back just a little bit, hopefully. Okay, I know this is like rewinding back to quarter 2. All right, now I got to get x by itself. So I'd subtract 4 from both sides. And then x equals negative 4 plus m minus 3i. Now, the reason I showed you that is because we're going to basically do that going backwards. We're going to start with that and then work our way back up to here to figure out that equation. All right. So let's work backwards now. Actually, I'll kind of try to put these like side by side so you guys can see what's going on. Okay. So here, I'm going to start with just positive. Not going to worry about the negative because I don't really need the negative to find the original equation. All right. So first thing is that here at that last step, I took away that number on this side and subtracted it from here, right? Which means I need to move the 2 back to the left side. So now if I move it back, that means I subtract it from both sides and get x minus 2 equals 3i. Okay, so now we're at this step over here, right? Now, if I go back up to the next step, that means before this was x minus 2 squared. If this is 3i, what was the number before? It would have been negative 9, just like this one. Okay, so I basically just squared this and then put a negative in front. Then I go back to this, I expand it back out. Okay, just like we have here. But now I need to multiply these two so I can go back to that step there. So if you can do it in your head, great. Maybe you need the box to multiply it so we can go backwards. So x squared minus 2x minus 2x and positive 4. So now it's x squared. Oops, sorry, that's a negative. So these two, negative 2 plus negative 2, negative 4, and then plus 4. Okay, and then the last step here is I want, notice how in that first step, I took away that c, or the last number, and brought it over here. Now I want to bring it back. So I'm going to add the 9 to both sides. And I get x squared minus 4x plus 13. And notice that is the same as that now. It's the same equation. Okay, but I had to work backwards using the completing the square method. All right. So that is those first 2 problems. Okay, that is really, and when you guys look in the packet, those are the only 2 that require you to do something like that, where you're using complex roots. After that, it's mainly just review. Like when you guys get down to here, it's asking about what is the degree, or first of all, decide if it's a polynomial. And if you guys remember from the week before, we took notes on that. Let me go back over to this packet. I think I wrote it down on this one. Where's my other one? Okay, we wrote down those different examples of like a polynomial can have no negative exponents, no variable exponent, has to be a degree of 2 or more, only 1 variable. This was from 8.12, so look back at that one to figure out which of these in today's assignment is and is not a polynomial. Okay, and then here you are basically taking these roots And I'll kind of do a quick little review of this one. You're taking these roots and creating the equation. All right, so again, for that one we just went over, this method is the one where you're going to do kind of the 3x3 box. The one on the right over here, you're going to be doing the square method that I just went over, or reverse complete square, okay? All right, so here you're going to do the 3x3 box. Oops, sorry. And then here, reverse completing the square. You can write this down or not write it down, because I mean, you can always go back and look at the video, or if you took a screenshot while I was working, then you can kind of just refer to that. Because when you get to this point right here, we had to set up a 3x3 box because we had 3 different terms right here. Okay, so that's why I called it 3x3. Okay, so now here on this one, this is again a review from last week. If I'm again writing another equation or polynomial, and that's 3/4. So, and it's asking you, by the way, to do it in standard form, which means you're going to have to multiply it out. I'm going to first write out the factors. Now, if it's just -2, then we know this is what? X plus 2. But if it's 3/4, what do I put here? It's 3/4 is the solution. The number on the bottom goes first, so I put 4x. That's positive 3/4, so what would I put after that? -3. Okay. And then you guys have to multiply all that out. So you're going to have to set up the box, multiply that out, and put it in standard form. This one, notice I've got 2 roots, but 1 point, which means I'm going to need to find the the stretch factor, A. So this was kind of like towards the end of last week, or the last folder, C. Here it's going to be x plus the square root of 5 and x minus the square root of 5. Okay, the first thing I'm going to need to do is find the A and plug in this point into the equation. So I'll plug in 12 here. Then I got to plug in the -3 to x. And then simplify this. And yes, you're going to do a box with square roots. Okay, so here I'm going to multiply out, because I can't really add these two, so I'm going to multiply them out. Actually, matter of fact, just to save you guys a little time here, you could just plug this into Desmos. I think that's probably the friendliest thing to do. Just take this, use the Desmos calculator to multiply that out, because there's no variables in there, so you could just literally type that out. And then whatever that number is, you divide that on both sides. Okay? So whatever you get from that, divide it onto both sides, and then write out your equation with the A. You're going to need that A, and then the rest of the other 2 factors. Okay. Okay, the only thing here is that you do need to it's asking for standard form. So, now that I'm thinking about it, you are going to need to multiply these out. Okay, so to multiply these out, I'm going to need to do the box because it wants standard form. And I'll put x and square root of 5 and x and square root of 5. Okay, I'll kind of get this started for you guys. So x squared here. Oh, sorry, one of these is minus, by the way. That was a minus there. So here I got x times square root of 5 minus x times square root of 5. Now we have to remember when I multiply two square roots, square root of 5 times square root of 5 is just 5. But one of them is negative, so it'll be negative 5. Also notice that these are the same number, but one is negative. So then what happens to those two? They cancel. So really, I just have x squared and minus 5, which you're going to need to put in there. And then once you have your a value, you're going to multiply it times those two numbers. Okay. So a lot of times when you're dealing with the square roots, it might be a little unfriendly up front, but a lot of times they cancel out at some point so that you end up with a little bit simpler equation. Okay. And then the back is more review. It's use domain, find the domain and range. You can do this with Desmos. This is write the inverse of the equation. We did that in the first week. And then find the domain and range of that. You can also use that Desmos for that. Remember, this is the one with parentheses and brackets, okay, or infinity and that sort of thing, okay. Here, multiplying them out imaginary numbers. And then the last one, you're just sketching this graph out. You can use Desmos again to kind of sketch it out. And then really you're just, the main part of this is just figuring out the domain and range. Okay, so there's real no math or algebra you're doing with this one. You're just figuring out the domain and range with these few problems here, okay? Okay, that is it for today. If you guys have any more questions, stick around. Otherwise, I will see you guys tomorrow in class or on Zoom. By the way, Ramadan Mubarak.